Okay, this is project test number one, and it's going to be problems 1 through 10 in this video. So the dot plot below displays the total number of miles that the 28 residents of one street in a certain community travel to work in one 5-day work week. So we have a dot plot. Which of the following is the closest percentile rank of residents from this street who traveled 85 miles to work? So we're interested in 85 miles to work, which is approximately right here. Now they're talking about a percentile rank. Well, percentile ranks go from negative infinity to the right. So we're going to have to move from negative infinity to the right. So we're going to count up until we get to 85. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is the 20th mark, and we have a total of 28. So our percentile rank is just going to be 20 over 28 equals x over 100. And we go ahead and solve that. 20 divided by 28, 20 divided by 28, and we get about 71%. So our best answer right here is going to be 71. So we get about 71.4. Our best answer is going to be B. All right. So B would be our best answer on that particular problem. Moving on to to question number 2. A large simple random sample of people aged 19 to 30 living in the state of Colorado was surveyed to determine which of 2 MP3 players just developed by a new company was preferred. To which of the following can the results of this survey be generalized? All right, first off, we generalize to the population. We always generalize to the population. Matter of fact, we never generalize to the sample. Why? We know the sample value, right? We know the sample value. We're trying to generalize to the population. So who do we generalize? We always generalize to the population that is most similar to the sample. So we generalize to the population most similar to the sample. All right, so what's most similar to their sample? People aged 19 to 30 living in Colorado. So only people aged 19 to 30 living in the state of Colorado who were in the sample? No, not who were in the survey. If it didn't have that, that would be good. But that right there is the sample. That's not the population. Only people aged 19 to 30 living in the state of Colorado. That is very similar. We actually like that response. We can't do it to all people living in the state of Colorado because it's only 19 to 30-year-olds. Only people aged 19 to 30 living in the US. We only looked at Colorado, and Colorado may have different tastes than other states. And obviously we can't do all people in the US because we don't have Colorado accounted for, nor do we have the age accounted for. So our best answer to number 2 is B. Moving on to question number 3. Janelle collected data on the amount of time and minutes each person in a large sample of customers spent in a local store. The data also included recording the gender of each customer. The data were used to generalize the box plots shown below. All right, please remember, we have our minimum value, our Q1, our median, our Q3, and our max. Also be careful. We have right here a minimum value of about 15, a Q1 value of about 10, the median or Q2 at 20. Right here, I'm going to guess that that's about 28 for Q3. And then my maximum value is at 90. So what is this value? This is the highest value that's not a maximum, but this is my maximum value. So the next thing, letter A. Which of the following statements is true? The range in the amount of time in minutes males in the sample of customers in the store is approximately 40 minutes. Well, the range is max minus min. Well, my max value happens to be 90. My minimum value is about 5 right here. So, and this is my maximum value. So my max is 85. It is definitely not 40. The mean amount of time in minutes males in the sample of customers spent in the store is approximately 20 minutes. They get you. Be very careful. First off, box plots, we can't find the mean. And it turns out the 20 is the median. But from a box plot, we can't find the mean, so we couldn't do this anyway. And that 20 happens to be the median. The third quartile of the amount of time in minutes males in the sample of customers spent in the store is approximately 45 minutes. All right. Well, our third quartile occurs right here, which is probably 28 to 29. That 45 minutes happens to be the largest value that was not an outlier. It's not the maximum value. The 90 is the maximum value. This is the largest value that's not an outlier. Third quartile occurs at the top of the box. The interquartile range is the amount of time in minutes females of the sample customers spent in the store is about 15 minutes. All right. So the interquartile range, well, interquartile is IQR equals Q3 minus Q1. So our Q3 right here, I'm going to guess is about 18 minutes. And our Q1 right here is about 7 minutes. So 18 minus 7 is 11. Now it's possible I didn't read that quite right. So we'll leave that as a possible answer and see if E's better. Approximately half of the males, because we think if they saying 15 minutes, and I'm getting a value that's definitely less than that. I'm getting probably about 11 here. So there's probably not this, but just in case, we'll put a question mark. Approximately half of the males in the sample of customers spend at least as much time in the store as any of the females. Well, as soon as they say half, we know we're talking about the midpoint. And the midpoint occurs at the median. So the median for the males is at 20. And sure enough, 50% of the males spend more than 20 minutes, which was the max value for the females. So consequently, our best answer on this one is letter E. All right, our best answer on the number 3 is E. Moving on to number 4. The probability of obtaining a head when a certain coin is flipped is 0.65. Which of the following is the closest to the probability that heads would be obtained 15 or fewer times when the coin is flipped 25 times? So we have a fixed probability. We have a probability of 0.65. That is fixed. We have a fixed number of trials. And the fact that we have a fixed number of trials lets me know fixed probability, fixed number of trials. This lets me know we're working with a binomial. So we're working with a binomial here. And which of the following is closest to the probability that heads will be obtained 15 or fewer times? Well, if I made my number line, I could have 0, 1, 2, 3, ... 14, 15, 16, ... all the way up to 25. Well, they say 15 or fewer. So this is what I'm interested in. Well, because it's multiple values, I know I'm going to be working with the binomial CDF. All right, we identified that it was a binomial. This is going to be a binomial CDF. And I'm going to go ahead and show my work as if this were a FRQ. Obviously, it's not, so I wouldn't have to. But if this had been a FRQ, I would be go 25, choose 0, 0.65 to the 0, 1 minus 0.65, which is 0.35. 25 minus 0 is 25. So this is my lowest value, plus I'm going to go dot, 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 plus, because essentially I'm going to do this for 0, then for 1, then for 2, then for 3, but we're going to shortcut it. We're going to just do lowest and highest. So 25, and then we're stopping at our highest value is 15. That's the highest thing we want. 0.65 to the 15th, 0.35, and 25 minus 15 is 10. So that would be work shown. Now on the calculator, it's going to be binomial, CDF. My trials are going to be 25. My probability is 0.65. And my number of successes, what I'm interested in the number of successes is 15. We want a max of 15. So let's do this. Second vars, binomial. Have to scroll a ways till we get to binomial CDF, which is letter B. Trials is 25, probability is 0.65, and my X value is 15. And I end up getting 0.369. Well, my closest to that is letter B, or 0.37. Moving on to number 5. A study was conducted using the data collected on birth weights of a random sample of 10 pairs of identical twins. So we see the word pairs and we think twins. It's like, this is probably a paired test, all right? But not necessarily. We need to keep reading. To determine whether the twin born first tends to weigh more than the twin born second. Let MF represent the average birth rate of all twins born first, and MS represents the average weight of twins born second. So I'm sitting there going, oh, we have an average of first and an average of second. That's two, that makes this two sample. That's not a paired. Let's keep reading. And MD, oh, so this is paired. So we have something that says this could be the MF and MS. If I subtract those two things, I have a two sample. But if I use the MD, I have a paired. So they're really throwing a lot of information for you to try to confuse you. MD represents the average difference in weight first minus second for all pairs of data. Which of the following would be the null hypothesis for this study? Well, which would be better? Would it be better if I compare the average weight of firstborns minus the average weight of secondborns? Or would it be better if I did the first one minus the second one? Well, if I do the first minus second, I control for differences from families, from birth, from prenatal care. And remember, if you can run a paired test, you should. Well, I obviously can run a paired test, so I want to use mu-D. Well, mu-D is always going to be set up with mu-D equals 0. And it always will be. And they wanted to see firstborn tends to weigh more. So they want the first one to be greater. So we need this to be greater. So this will be an alternative of mu-D greater than 0. So HO and HA. So mu-D equals 0 and mu-D is greater than 0. This is a difficult problem because they gave you both options. All right, they told you about the two sample, but they also told you about a paired. So you needed to know that, hey, if I can run a paired, that's a better choice. This right here doesn't exist. We don't do the average of the first minus the average of the second equals the difference. Can't do that. You have to do the first one minus the second one. So this is just totally wrong. And this is if we were running a, these would be based if we were running a two sample. Okay, all right. And technically they're wrong as well too, because this would have needed to be a greater than. But the main thing is know that this was paired because we were working with twins. All right, number 6. The buyer for an electronics store wants to estimate the proportion of defective wireless game controllers in a shipment of 5,000 controllers from the store's primary supplier. The shipment consists of 200 boxes each, containing 25 controllers. The buyer numbers the boxes from 1 to 200 and randomly selects 6 numbers in the range. She then opens the 6 boxes with the corresponding numbers and examines all 25 controllers in each of these boxes. This is really important, all 25 in each of the boxes, and determines the proportion of controllers that are defective, what type of sample is. Well, there's no reason to think this was biased. Besides, there's no such thing as a biased random sample. You can take a random sample with bias, but generally speaking, bad idea to put those 2 words together, because randomness helps eliminate the bias part. We definitely use randomness because we number from 1 to 200 and randomly selected, so non-random's not. Simple random sample. To be a simple random sample, every single controller had to have an equal opportunity in every group. So that means I would need to be able to make sure that I'd select one from one box, one from the other box, etc. And this was not available because once I selected a box, I counted all the ones in there. So this is not a simple random sample. Not every combination was possible. So we have a stratified, or we're down to stratified or cluster, and really we should have jumped at this immediately because we knew we broke it into groups. Anytime you break it into groups, you're dealing with one of these. Now, with the stratified sample, you choose from every group. So if this were to be a stratified sample, I would choose from each one of the boxes and then do a random sample within the box. That would be stratified. Choose each box, and then do a random sample. All right. Well, she didn't choose each box. She randomly selected the box and then did a census. Randomly select group or groups, put an S on that, and then conduct a census. We know she conducted a census because it said she surveyed all of them. She randomly selected a box, then she conducted a census. This is a census, this is a cluster. Number 7, a distribution of test scores is not symmetric. That's pretty important. Which of the following is the best estimate of the z-score of the 3rd quartile? So we're going to write down our z-score formula. Z equals x minus mu over sigma. And you're like, you know what? 3rd quartile, that's 75%. So you start drawing a normal curve and you go, okay, 3rd quartile, this is a z of 0 at the mean, and I want this shaded area to be 0.75. And had this been normal, we could do an inverse norm of 0.75. All right, we could do an inverse norm of 0.75 when we get a z-score right here. We know it's going to be a positive value, etc. But they didn't tell us it was normal. All right, and because they didn't tell us it was normal, we cannot do the inverse norm. So we cannot do the inverse norm because they didn't tell us it was normal. As a matter of fact, they wanted you to know that it wasn't normal. They said it was non-symmetric. So that's obviously not normal. But even if it had been symmetric, if they don't tell us it's normal, we can't use the inverse norm. So the z-score cannot be estimated because we don't have enough information. All right, the z-scores cannot be information. It cannot be done. And they gave us a pretty big hint when they said it was not symmetric. They wanted you to get that one right. All right, chi-squared. Number 8. Sophomore, juniors, and senior students at a high school will be surveyed regarding a potential increase in the extracurricular student activity fee. There are 3 possible responses. agree with the increase, do not agree with the increase, or no opinion. A chi-square test will be conducted to determine the response to the question is independent. So we're looking at a test, a chi-square test of independence. Of independence. How many degrees of freedom should be used in the chi-square test? Well, first off, what is the formula for degrees of freedom for chi-square? Or chi-square test of independence. The chi-square test of independence, it's rows minus 1 times columns minus 1. You're like, uh-oh, that's a problem. I don't have any rows or columns. So I need to go back and reread this thing. And when I do, I find out I have some categories. So first off, I have sophomores, juniors, and I also have seniors. That could be 3 rows. It could be the 3 columns. It really didn't matter which way I broke them up. And agree, disagree, no opinion. Oh, so I have three rows, 3 columns. So this is going to be 3 minus 1 times 3 minus 1, which is 2 times 2. My degrees of freedom in this case happens to be 4. All right. So that was a chi-square test of independence. And once again, you're going to have to memorize rows minus 1 times columns minus 1. All right. Problem number 9. A certain type of remote control car has a fully charged battery at the time of purchase. The distribution of run times of this car of this type before they require recharging the battery for the first time after its period of initial use is approximately normal with a mean of 80 minutes. So that we're telling me this is 80. So we're centered at 80 with a standard deviation of 2.5. So we have mu equal 80, and we have a standard deviation of 2.5. The shaded area in the figure below represents which of the following probabilities? Well, I see mean minus 2 standard deviations. Okay, so that means this side is going to be 80 minus 2 times 2.5. Well, 2 times 2.5 is 80, so 80 minus 5 tells me this value is about 75 minutes. Over here, it's 80 plus 2.5, and that gives me this value right here at about 82.5. So basically, we're looking at about 75 to 82.5 minutes. So the probability that the running time, this is A, of a randomly selected car of this type before it requires recharging of the battery for the first time after its period of initial use is between 75 and 82.5. So this shaded area, the low is 75, the upper is 82.5. Letter A happens to be the correct response for this one, because the shaded area is 75 to 82.5 minutes. All right, number 10. Which of the following scatter plots could represent the data with a correlation coefficient of R equals -1? Well, the fact that it's negative means it should be, I should have a downward slope. And the fact that it's a 1 tells me it should be a straight line. So this is downward and about a straight line. This is going to be letter A. However, just so you know, this is going up. It's going to be positive, but it's going to be some value between 0 and 1 because it's not a perfect line. This one is going up. It's positive. It's about a perfect line. So this would be about a positive 1. This, I have no idea whether to draw the line this way, this way. Since I don't know the direction of the line, my R value right here would be 0. When I look at this one, I have a horizontal line. And yeah, it's a nice straight line, which makes you want to think that it's 1. But because it's horizontal, I don't see a relationship between X and Y, because it doesn't matter what X is, Y is 2. If X is 60, Y is 2. So because there is no relationship, R is 0, right? Even though this is a straight line, because it's a horizontal line, that's a special case of it. There's no relationship. It doesn't matter what X is, Y stays the same. So this is 0. So E is wrong, C is wrong. And the reason A is right is it's negative because it's going down. So we have a negative relationship and we have about a straight line. And if we have a straight line going up or going down, we're going to have a 1. In this case, it's going down, which makes this a -1. And this is what they were looking for. All right, this concludes the first video for the first test.